Okay, at what points? Maybe more than one point. At what points on the hyperbola with hyperbola, hyperbola xy equals 12 is the tangent line parallel. The tangent line is parallel to the line 3x plus y equals 0. Okay. Hyperbola here is like reciprocal curve. Okay. When x is given, y can be solved. Y equals 12 over x. So we may regard y as a function of x. Once x is given, y can be solved. We can solve y in terms of x. Okay, for this line, this line passes through the origin and with slope minus 3. Okay. At what points on this hyperbola is the tangent line parallel to, parallel means parallel, huh? So we have to find the 2 points. At these 2 points, the tangent lines to this curve, to this hyperbola, are parallel to this line. Parallel to this line means that the slope, they have the same slope. Slope equals minus 3. All we have to do is find the slope function. Equals minus 3 is equivalent to minus 3 equals minus 12 over x squared. When x equals minus 2, this is minus 6. So at these 2 points, minus 2, minus 6, and 2, 6, the tangent lines passing through these 2 points to this curve will be parallel to this straight line. Okay, this and this section. We still have some time. The next section is talking about derivatives of trigonometric functions. Okay, there are 6 trigonometric functions, sine, cosine, tangent, cotangent, secant, and then cosecant. Their derivatives derivative of sine is cosine. And the derivative cosine is minus sine. We will derive all these 6 formulas. The derivative of tangent is secant squared. And the derivative of cotangent is minus cosecant squared. The derivative of secant is secant tangent. Finally, the derivative of cosecant is minus cosecant cotangent. Finally, we have to memorize this. You had better derive and derive again, and finally you're more and more familiar with these formulas. Because in the future, these formulas will be used frequently. In order to derive these formulas, we need to use the this limit. We already learned this before. Okay, in chapter 1.5, limit. When we review trigonometric functions, and finally we use some geometric interpretation and obtain the sum inequalities. Finally, use squeeze theorem to obtain this result. Okay, beside of this, we already proved this one. About this one, we can obtain this one by using the first one. Okay, in order to get this result, let's consider this one. And multiply both top and bottom by cosine h plus 1. Then the denominator will be a cosine squared h minus 1, and this is the denominator. Use the Pythagorean property, identity. The numerator is minus sine squared. Okay. We modify this expression in order to use the result we have derived before. So, sine squared h here, h squared h, so we can only one h here. Minus sine is here, and finally we have cosine h plus 1. Okay, this is the identity function or polynomial function whose limit is 0. And this is 1 here. And this is cosine 0 plus 1. And this is 0. Okay? So, as I mentioned before, this limit, the geometric interpretation of this limit is when h of x is nearby 0, then the value of sine x is almost x. So the slope of the tangent to this curve at origin is 1. But here means the slope of the tangent of cosine is 0. When at 0, the slope is exactly cosine 0 plus h minus cosine 0 over h. Same. This is the limit of a difference quotient. So the first limit is the slope of the curve at the origin. And the second limit, 0, is the slope of the tangent to this curve at x equals 0. Okay. Then we use these two famous limits. This one and this one can be derived. And then the rest 4 functions are maybe quotient or reciprocal of these 2 functions also can be derived immediately. And we will do this next time. Thanks. See you next week. Bye-bye.